Hello everyone, welcome back to my channel again. So let us continue the series problems of or a series session of problems on initial conditions from module 3. So let us consider one more problem now. Therefore the circuit shown in the figure, the switch K. See now we'll be having three conditions. One, and here it is two, and the switch is here, that is K. The switch is closed or the switch is changed from position. Initially they are given this position. Switch is at initially at 2. Initially switch is at 2, and see the arrow mark in this arrow. That is when t equals to 0, K is at 2. So before closing switch means when t equals to 0 minus K is at 1. Again when t equals to 0 plus K is at 2 before closing switch, or else before the initial value K is at 1. Again after 2, 0 minus idaga 1 ಅಲ್ಲಿ ಇರುತ್ತೆ, 0 plus idaga 2 ಅಲ್ಲಿ ಇರುತ್ತೆ. ಇಷ್ಟೇ logic. Okay, and I given one condition. Steady state condition having been reached at position 1 means when switch is at position 1, so the circuit will be behaving under steady state condition. What steady state condition says? If there is an inductor, that will act as short circuit under steady state. Similarly, if there is a capacitor, that will be act as open circuit under steady state. Only these 2 points you should have to remember. So now, without wasting time now, again we need to find I di by dt, d square I by dt at t equals to 0 plus is nothing but you need to find I of 0 plus di of 0 plus divided by dt. Again d square I of 0 plus divided by dt. Before that, let's write about switch. Switch K. Switch K implies that what it implies, you need to write the positions before closing or else after switching. Okay, so that is nothing but switch is at position 1 when it is position when the switch is at position 1 at sorry if the switch is at position 1, the switch is at position 1 when t equals 0 minus. Similarly, the switch is at position 2 when t equals 0 plus. Before closing or else at t equals to 0 minus, you can see I just explained earlier itself about the switch. You just see the arrow, tail end is nothing but 0 minus side, arrow end is nothing but 0 plus side. If there is an arrow mark like this, tail end is 0 minus side, arrow end is 0 plus side. So that if there is a 0 minus which is at 1, if there is a 0 plus which is at 2. But here the condition is if the switch is at position 1, there will be steady state condition. So that at t equals 0 minus, inductor act as a short circuit and capacitor act as open circuit. Is this clear? Therefore, when t equals 0 minus, circuit becomes, you need to draw the circuit. When t equals 0 minus, the circuit will be like this. There will be 20 volts plus minus of 20 volts. So now at position 1, switch is at position 1 now. Here there is a resistor R, the value of R is 10 ohm, and when the switch is at position 1, the circuit will be acting under steady state, so that inductor will be short circuit. So under steady state condition, inductor is short circuit and this capacitor is open circuit, since there is no element which is connected across capacitor, so that before closing switch at t equals to 0, Here I of 0 minus current is flowing, and the voltage across capacitor is Vc of 0 minus. What will be the value of Vc of 0 minus? That is nothing but 0 volts. You need to find the value of I of 0 minus. Just apply Ohm's law. I of 0 minus is nothing but 20 volts divided by 10 ohm, V by R, whereas V is 20, R is 10. You can get 2 amperes. And since current flows through inductor L cannot change instantaneously, cannot change instantaneously. Therefore, I of 0 minus is same as I of 0 plus. I explained in previous videos. I of 0 minus is same as I of 0 plus. That is nothing but 2 amperes. Similarly, Vc of 0 minus, just now we got Vc of 0 minus is nothing but 0. And also Vc of 0 minus equals to Vc of 0 plus, that is equals to 0 volts. Again, since voltage across capacitor C cannot change instantaneously. Therefore, Vc of 0 minus equals to Vc of 0 plus. What they asked you to find? They asked you to find the value of I of 0 minus, so that we got the value of I of 0 minus. So I of 0 minus is 0, sorry, 2. Therefore, I of 0 minus, that is equals to I of 0 plus, that is equals to 2 amperes. Similarly, Vc of 0 minus equals Vc of 0 plus equals 0 volts. So now, when the switch is at position 0 plus, to find the derivatives, that is di of 0 plus by dt and d square I of 0 plus by dt, you need to find the value of, sorry, you need to write the equation. So equation you need to write. So therefore, at switch, sorry, when t equals when t equals 0 plus, switch will be at position 2. When t equals 0 plus, switch will be at position 2. Therefore, circuit becomes, so switch position is at 2. Here there will be resistor of 10 ohm. Here there is no steady state condition, so that you are not doing anything. You are just writing as it is. And from 2 to there will be capacitor like this. We will draw it once again. So from here, inductor, and from here, capacitor you are connected. The circuit which looks like this, and current flows to this is now I of 0 plus. You already know the value of I of 0 plus, that is 2 amperes. Keep that in your mind. And the value of capacitor, you know, that is C equals to 1 microfarad, and R, you know, that is nothing but 10 ohm. L they are only given, that is nothing but 1 Henry. So now apply KVL to get the derivatives of currents, that is di of 0 plus and d square I of 0 plus divided by dt square. So now you can see, apply KVL, apply KVL, you can get the voltage. There is no voltage here, so that equals to 0, so that R into current flows, that is I of 0 plus voltage across L is nothing but L into di of 0 plus divided by dt. L into di by dt is voltage drop across L, plus voltage drop across C is nothing but 1 by C into integration of I of 0 plus into dt equals to 0. KVL. Give this as equation number 1. Okay. And what this 1 by C at 1 by C into integration of I of 0 plus at dt indicates, that is nothing but Vc of 0 plus, voltage across capacitor, and this is voltage across inductor, this is voltage across resistor. Therefore, I'll write R into I of 0 plus L into di of 0 plus divided by dt plus 1 by c into integration of I of 0 plus I of 0 plus into dt. I can rewrite it as Vc of 0 plus. This is nothing but Vc of 0 plus equals to 0. What is the value of Vc of 0 plus? That is nothing but 0. And you know that I of 0 plus equals 2 amperes and Vc of 0 plus equals 0 volts. Substitute here, you can get the values. R is nothing but 10. 10 into 2. I of 0 plus is 2 plus L value. L is nothing but 1 into di of 0 plus divided by dt plus Vc of 0 plus is nothing but 0 equals to 0. 10 into 2 is nothing but 20. Right, send that into right side. You can get the first derivative that they asked, di of 0 plus divided by dt is nothing but minus 20 ampere per second. And what is the value of I of 0 plus? I of 0 plus is 2 amperes. Next, what you need to find? D square I of 0 plus, so that to find d square I of 0 plus, what you have to do? Differentiate equation 1 with respect to t when t equals to 0 plus. When t equals to 0 plus, so that do the differentiation of this equation, you can get r into differentiation of I of 0 plus with respect to t is nothing but di of 0 plus divided by dt plus differentiation of L into di of 0 plus by dt is nothing but L into d square I of 0 plus divided by dt square. This is our required derivative. 1 by c into I of the integration of I of 0 plus into dt. Integration and differentiation will get cancelled. You can get plus I of 0 plus divided by c equals to 0. Now we substitute the value. The value of r is 10. 10 into di of 0 plus divided by dt is nothing but minus 20. 10 into minus 20 plus the value of L is 1. 1 into d square I of 0 plus divided by dt square plus I of 0 plus is nothing but 2 divided by the value of C is 1 microfarad. That's nothing but 1 into 10 to the power minus 6 equals to 0. So now we'll get the value of d square I of 0 plus by dt square. So that d square I of 0 plus divided by dt square equals 20 into 10 is nothing but 200. Send that into right side. That's nothing but 200 minus 2 divided by, or else minus 2 into 10 to the power 5. So 10 to the power 6 minus 6, you are sending into the numerator, it becomes plus 6. 200 minus this one, you can get 200 minus 2 into 10 to the power 6. So you can get approximately minus 1.99 into 10 to the power 6. You can get minus 1.999 into 10 to the power 6 is nothing but minus 2 into, or else equivalent to minus 2 into 10 to the power 6 ampere per second square. This is d square I of 0 plus divided by dt square. the required value. I hope you are getting this. It is very easy, don't get confused. So first you need to find before closing switch, then you need to write, or else then you need to find after closing switch. If you want, you can take screenshot before closing switch, or else at t equals to 0 minus switch position is 1, at t equals to 0 plus switch position is 2. ಪೊಸಿಷನ್ 1 ಅಲ್ಲಿ ಇದ್ದಾಗ ಸ್ಟಡಿ ಸ್ಟೇಟ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಅವಾಗ ಇಂಡಕ್ಟರ್ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಆಗುತ್ತೆ, ಕೆಪಾಸಿಟರ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಇದು ಸರ್ಕ್ಯೂಟ್ ಜಸ್ಟ್ ಸಿ ಹಿಯರ್, ಈ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಆಗಿರೋದು ಇಂಡಕ್ಟರು, ಕೆಪಾಸಿಟರ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಆಗಿದೆ, ಅದು ಯಾವುದೇ ಎಲಿಮೆಂಟ್ಸ್ ಕನೆಕ್ಟ್ ಆಗಿಲ್ಲ, ಅದಕ್ಕೆ ವೋಲ್ಟೇಜ್ ಅಕ್ರಾಸ್ ಕೆಪಾಸಿಟರ್ ಇನಿಷಿಯಲಿ ಏನಾಗುತ್ತೆ ಝೀರೋ ಆಗುತ್ತೆ. ದಟ್ ವಿಲ್ ಬಿ ಸೇಮ್ ಇವನ್ ಇಫ್ ಯು ಚೇಂಜ್ ದ ಸ್ವಿಚ್ ಪೊಸಿಷನ್, ಯಾಕಂದ್ರೆ ವೋಲ್ಟೇಜ್ ಅಕ್ರಾಸ್ ಕೆಪಾಸಿಟರ್ change ಆಗೋದಿಲ್ಲ if it is a before closing switch or else after closing switch. So the same that will be applied for the inductor also. It won't change, the current flows to the inductor, it won't change before closing and after closing switch, so that you need to get the current flowing through the inductor, that is I of 0 minus is nothing but voltage by resistor. Simple Ohm's law, 20/10 2 amperes. ಅದಾದ್ಮೇಲೆ ಸ್ವಿಚ್ ನ ಕ್ಲೋಸ್ ಮಾಡ್ತೀರಾ, or else switch position change ಮಾಡ್ತೀರಾ 2 ಗೆ. when t equals to 0 plus switch is at position 2, then you are applying KVL, you are giving that as equation 1. 1 by C into integration of I of 0 plus into dt is nothing but voltage across capacitor. So ಅದರ ಬದಲು VC of 0 plus ಅಂತ ಬರ್ಕೊಳ್ತೀರಾ, because the value of VC of 0 plus is 0. Then you're substituting, you will get the value of di of 0 plus by dt, that is minus 20 amperes. Next ಏನು ಮಾಡ್ತೀರಾ, ಬಂದಿರೋ equation 1 ನ differentiate ಮಾಡ್ತೀರಾ, then substituting the values, simplifying the equations, you'll get d square I of 0 plus by dt square. This is also very important, they asked many times in the examination. If you're having any doubts regarding this, feel free to write in the comment box. And also, if you really like this video, I hope everyone subscribe and share to your friends maximum. Thank you so much. Have a nice day.